So rotational kinematics is very similar to linear kinematics in the sense that everything that we've learned so far, you can just make analogies to it from linear kinematics into rotational kinematics to make it easier for you. So for linear kinematics, the first thing we learned was distance. So distance we were able to measure as meters, and we always used the variable x. So that was the first thing we learned. We learned that it's measured in meters, and what you do is it's basically the shortest path between 2 points in a straight line. The next thing we learned was velocity, which is a rate of change of displacement, or a rate of change of distance. And that we just used v. After that we learned acceleration, which was the rate of change of velocity over a given period of time. So all of these analogies we can make in rotational kinematics like so. For distance, your variable is theta, which stands for degrees, and it's usually used in radians. After that, instead of velocity, we're going to have omega, which is going to be angular velocity, which is equal to theta degrees for every unit of time, similar to velocity. After this, we have the last thing, which is angular acceleration. That's shown as alpha. It's just like normal acceleration, except it's used in degrees theta per time squared. So it's theta per time squared, similar to meters per second squared. Same way omega is similar to meters per second. So because these are all the same variables and they would have the same results if used in equations, we can use the exact same equations that we use for linear kinematics and use the same thing, except just change around our distance, our velocity and acceleration, and in turn use the analogies in rotational kinematics, such as alpha, omega, or theta.